You arrive in stillness, not just the absence of sound, but a profound, almost tangible silence that wraps around you like a shroud. It's a stillness that permeates the air, that settles on the vast, white expanse before you. This is Antarctica, the bottom of the world, a continent sculpted not by time, but by eternity, frozen in place. Imagine stepping onto a landscape where the horizon ceases to exist, where the white of the snow seamlessly bleeds into the pale sky. The air is so crisp, so clean, it bites at your lungs, a stark reminder of the raw, untamed nature of this place. The sun, a weak disk in the sky, casts long, unwavering shadows, accentuating the starkness of the terrain. This is a world stripped bare, seemingly devoid of life, a landscape of unending white. But don't be deceived by this initial impression. Don't let the surface fool you into thinking this is a desolate wasteland, a place of nothingness. For beneath this icy mask, beneath this frozen stillness, lies a world brimming with secrets, a hidden realm of dynamic processes and surprising life. We often perceive Antarctica as a static, unchanging block of ice, an unyielding fortress against the elements. But in reality, it's anything but. Picture colossal ice sheets, some of them stretching miles deep, dwarfing even the grandest canyons on other continents. These aren't inert slabs of frozen water. They are rivers of ice, albeit incredibly slow-moving ones. Think of them as frozen waterfalls cascading towards the sea at a glacial pace. They grind and groan, they creep and shift, their immense weight reshaping the land over millennia. This is not the stillness of death, but the stillness of immense, almost imperceptible movement, a force so powerful it defies human comprehension. And then, consider the surface itself, the seemingly uniform expanse of snow. Look closer, examine the individual snow crystals, each one a tiny masterpiece of natural artistry, sculpted by the relentless wind and the fluctuating temperatures. They form intricate patterns, delicate lattice, and complex geometry. Each crystal is unique, a fleeting work of art, constantly evolving and rearranging, a testament to the hidden beauty that lies even in the most extreme environments. It is a living, breathing tapestry of frozen water, an ever-changing canvas painted by the elements. But even this breathtaking surface is just a prelude to the real wonder that lies beneath. Prepare to venture deeper, beyond what the eye can see, beyond what seems possible, because buried beneath miles of solid ice, insulated from the crushing pressure and the eternal cold, exists a hidden network of rivers and lakes, a subglacial world teeming with liquid water. Imagine that, for a moment, a vast subterranean realm, untouched by sunlight for millions of years, a place where water flows freely beneath a frozen continent. It seems almost fantastical, doesn't it? A hidden oasis in the heart of the frozen desert, a testament to the surprising resilience of our planet. These subglacial rivers aren't raging torrents, carving deep valleys with furious speed. Instead, they are slow, deliberate streams, warmed ever so slightly by the Earth's internal heat and the immense pressure of the ice above. They meander and weave their way through the bedrock, threading their way through ancient landscapes, acting as a hidden circulatory system for the continent. And the lakes, vast reservoirs of ancient water, like Lake Vostok, sealed off from the outside world for millions of years. They are time capsules, holding secrets of past climates and ecosystems, offering glimpses into a world long lost to the surface. Imagine the possibilities. Ancient microbes preserved in pristine condition, climate data stretching back millennia, all locked away in these hidden bodies of water. They are like pages from a lost history book, waiting to be read, waiting to reveal the secrets of our planet's past. These hidden waterways are not just geological curiosities. They are vital components of the Antarctic ecosystem, influencing the flow of ice, the transport of sediment, and the distribution of life. They act as a lubricant, allowing the ice sheets to slide more easily towards the sea. They transport nutrients and minerals, sustaining life in the most unexpected places. They are a testament to the power of water to persist, to adapt, to find a way, even in the most extreme environments. So, as you stand on the frozen surface of Antarctica, surrounded by the overwhelming stillness, remember what lies beneath. Remember the hidden rivers, the ancient lakes, the slow, deliberate currents that shape this frozen continent, and let that knowledge inspire you to look beyond the surface, to question your assumptions, and to open your mind to the wonders that exist even in the most unexpected places. Let's delve deeper into this realm of white. Let's truly see what's there, and in doing so, perhaps see something more within ourselves. The frozen canvas stretches before you, an immensity of ice and snow painted with the softest strokes of light and shadow. It's a landscape where the horizon seems a theoretical construct, a line perpetually receding as you approach. The sheer scale of it all can be overwhelming, dwarfing your sense of self and forcing you to confront the raw, untamed power of nature. Imagine fields of snow, sculpted by the relentless winds into undulating dunes, frozen waves of white that mimic the ocean swells far to the north. These aren't the pristine, powdery slopes of a ski resort. This is a landscape marked by the harsh realities of survival, where every ridge and hollow tells a story of wind, temperature, and time. Look closer, and you'll begin to notice subtle variations in the snow. The wind-packed drifts, hard and unforgiving, contrast sharply with the softer, more granular snow that settles in sheltered areas. The sun, even in its diminished winter form, etches delicate patterns onto the surface, creating intricate designs that shift and change with the passing hours. The ice itself takes on many forms. There's the smooth, glassy surface of glacial ice, polished by centuries of relentless movement. There are the jagged peaks of icefalls, frozen waterfalls of immense power, their surfaces fractured and scarred by the constant pressure. And there are the towering icebergs, sculpted by the ocean into fantastical shapes, each a unique work of art carved by the forces of nature. The color palette, while seemingly limited to shades of white and blue, is surprisingly diverse. The purest snow reflects the sunlight with blinding intensity, while the deeper ice absorbs the light, revealing hues of sapphire and turquoise. Shadows deepen the blues, adding depth and dimension to the landscape, hinting at the vastness that lies beneath. And then there are the sastrugi. These are wind-sculpted ridges of snow, often razor-sharp and aligned with the prevailing winds. They can be deceptively beautiful, but they also serve as a constant reminder of the harsh conditions that prevail in this environment. Navigating through a field of sastrugi can be a challenging and even dangerous undertaking, requiring careful attention and a respect for the power of the wind. But don't let the stark beauty fool you into thinking this is a static, unchanging world. Even in the depths of winter, when the sun barely peaks above the horizon, the landscape is constantly evolving. The wind continues to sculpt the snow, the ice continues to shift and grind, and the subtle changes in temperature cause the surface to expand and contract. It's a slow, deliberate dance of frozen elements, a ballet performed on a scale that dwarfs human comprehension. And while it may appear barren at first glance, it's a landscape teeming with hidden details, with subtle textures and colors that reveal themselves to those who take the time to look. Consider the frost flowers, delicate, crystalline structures that form on the surface of the ice when the air is cold and moist. These ephemeral creations are as intricate and beautiful as any snowflake, each one a testament to the hidden artistry of the natural world. They form and disappear with the changing weather, their existence a fleeting reminder of the delicate balance of this environment. Or look at the patterns formed by the wind on the snow surface. The wind creates ripples, dunes, and swirls that resemble landscapes. Every snow particle's placement is the result of natural forces, an equation written over miles. The frozen canvas is a record, etched over millennia, of every storm, every freeze, every thaw, every shift in the planet's climate. It's a history book written in ice and snow, waiting to be read by those who have the patience and the understanding to decipher its secrets. And while it may appear desolate and unforgiving, it's also a landscape of immense beauty, of profound stillness, and of boundless potential. So, as you stand on this frozen canvas, take a moment to appreciate the subtle details, the hidden textures, and the quiet beauty that surrounds you. For even in this seemingly barren land, there is life, there is motion, and there is a story waiting to be told. You simply need to know where to look, and, perhaps more importantly, how to listen. Because the canvas itself, in its stark white beauty, is only the beginning. What lies beneath, what flows unseen, is where the true wonders await. But let's challenge that initial judgment. This vast expanse isn't a lifeless void, merely frozen. It's a stage, a grand glacial theater, where life plays out in subtle, often unseen ways. Our human eyes, accustomed to lush forests and bustling cities, might struggle to perceive the delicate dance of existence here. But it's there. Think about it. Life doesn't necessarily require warmth, sunlight, or the familiar comforts we associate with flourishing ecosystems. It requires opportunity, adaptation, and a relentless drive to persist. And Antarctica, despite its apparent hostility, offers these in surprising abundance. The very snow that blankets the landscape, seemingly uniform and sterile, teems with microscopic organisms, algae, bacteria, and fungi, specially adapted to thrive in the extreme cold, colonize the snow surface, creating vast, albeit invisible, meadows of life. These hardy organisms, known as snow algae, tinge the pristine white with shades of pink, green, and even orange, painting subtle masterpieces across the frozen canvas. You might not notice them at first glance, but they are there, silently photosynthesizing, contributing to the delicate balance of the Antarctic ecosystem. And consider the ice itself. It's not merely a solid, impenetrable barrier. It's a complex matrix of frozen water, laced with pockets of liquid brine, microscopic channels, and air bubbles. These tiny havens provide refuge for even more extremophiles, organisms that love the extreme. Bacteria, archaea, and even small invertebrates find sanctuary within this frozen labyrinth, forming miniature ecosystems within the heart of the ice. They represent an entirely unique ecosystem within the ice itself. But the surface isn't the only place where life finds a foothold. Consider the coastal regions, where the ice meets the ocean. Here, nutrient-rich waters support a diverse array of marine life, from tiny plankton to colossal whales. Seals bask on ice floes, penguins waddle across the frozen landscape, and seabirds soar overhead, drawn to the bounty of the Antarctic seas. These animals, seemingly out of place in such an extreme environment, are a testament to the resilience of life and its ability to thrive even in the face of adversity. The key is understanding adaptation. Over millennia, life in Antarctica has evolved to cope with the challenges of the frozen continent. Organisms have developed unique strategies for surviving the extreme cold, the intense UV radiation, and the limited availability of water and nutrients. They have learned to conserve energy, to withstand dehydration, and to repair damage caused by freezing temperatures. They are masters of survival, honed by the relentless forces of evolution. So, the next time you see a picture of Antarctica, a vast expanse of white stretching to the horizon, remember that it's more than just a frozen wasteland. It's a hidden world, a realm of subtle beauty and extraordinary resilience. It's a place where life finds a way, even in the most challenging of circumstances. Look beyond the surface, and you'll discover a vibrant, thriving ecosystem, teeming with life that is just waiting to be seen, and perhaps, in doing so, you'll gain a new appreciation for the tenacity of life and its ability to flourish in even the most unexpected places. Because in the end, isn't that true of all of us? We are, each of us, extremophiles in our own way, adapting and thriving in a world that often feels just as harsh and unforgiving as the frozen plains of Antarctica. But this grand frozen expanse isn't just a static monument to the cold. Beneath that seemingly unyielding surface, a dynamic world unfolds, a world of colossal ice rivers, moving with a power that reshapes the very landscape. Imagine, if you will, immense sheets of ice, some stretching for hundreds of miles and plunging to depths exceeding to miles. That's deeper than the Grand Canyon. These are not merely frozen plains. They are dynamic ice rivers, constantly in motion, albeit at a pace almost imperceptible to the naked eye. Think of these ice streams as gigantic, sluggish conveyor belts, slowly but surely carrying ice from the heart of the continent towards the ocean, driven by gravity and the relentless pressure of accumulated snowfall. They creep, slide, and deform, sculpting the land beneath them with unimaginable force. It's a slow-motion ballet of ice, a geological dance that has been playing out for millions of years. Now, you might be wondering, how can something so massive and cold actually flow? Well, the answer lies in a fascinating interplay of factors. Firstly, the sheer weight of the overlying ice exerts immense pressure on the ice below. This pressure lowers the melting point of the ice, creating a thin layer of meltwater at the base, acting as a lubricant that allows the ice sheet to slide more easily over the bedrock. Secondly, the Earth itself plays a part. Geothermal heat, rising from the planet's interior, warms the bedrock, further contributing to the formation of this lubricating layer of water. It's like a hidden heating system, subtly coaxing the ice to move. And thirdly, the ice itself is not a uniform, rigid structure. It's a complex material composed of countless individual ice crystals. These crystals can deform and reorient themselves under pressure, allowing the ice to gradually flow and change shape. Think of it like a very, very slow-moving glacier. But on a continental scale, these dynamic ice rivers are not uniform in their movement. Some areas flow much faster than others, forming what are known as ice streams. These are essentially fast-flowing rivers of ice, carving deep channels into the bedrock and transporting vast quantities of ice towards the coast. They are the arteries of the Antarctic ice sheet, channeling ice from the interior to the sea. Scientists use a variety of techniques to study these ice streams. Satellite imagery, radar, and GPS measurements reveal the subtle movements of the ice surface, while ground-based surveys and ice core drilling provide insights into the ice's internal structure and composition. One of the most fascinating discoveries has been the identification of subglacial lakes and water systems beneath these ice streams. These hidden lakes and rivers act as a sort of plumbing system for the ice sheet, influencing the flow of ice and the transport of sediment. They can also dramatically affect the speed at which the ice moves. A sudden surge of water into an area of ice could significantly increase the ice flow speed, contributing to sea level rise. Imagine the scale of this process. These ice rivers are not just eroding the bedrock beneath them. They're also transporting vast quantities of sediment towards the ocean. This sediment plays a crucial role in marine ecosystems, providing nutrients for marine life and influencing ocean currents. The movement of the ice directly impacts the ocean, proving that the Antarctic ice sheets aren't isolated entities. The study of these dynamic ice rivers is crucial for understanding the future of Antarctica and its impact on global sea levels. As the climate warms, the ice sheets are melting at an accelerating rate. Understanding the dynamics of ice flow is essential for predicting how quickly the ice will melt and how much sea levels will rise. It's like having to understand a car's engine to predict its performance. We need to understand the underlying mechanisms to be able to make predictions about the future. These ice rivers are a reminder that even in the most seemingly frozen and unchanging environments, there is constant motion and transformation. Antarctica isn't just a frozen wasteland. It's a dynamic and ever-evolving landscape, shaped by the relentless forces of ice, water, and gravity. And within these colossal ice rivers, ancient stories and secrets await to be discovered. They are a vital part of our planet's system, and understanding them is critical for understanding our planet's future. Now, let's consider the surface itself. We see the vast expanse of white, the seemingly endless plains of snow. But look closer, far closer, with a magnifying glass, with the eyes of a patient observer. You'll begin to notice the intricate artistry that blankets this frozen world. Forget the blank canvas. Imagine instead a field of billions, trillions of perfectly formed individual snow crystals, each one a tiny masterpiece, a testament to the laws of physics and the sheer beauty of natural geometry. These aren't just shapeless blobs of frozen water. These are intricate hexagonal structures, each one unique, each one sculpted by the precise conditions of its formation. The temperature, the humidity, the wind, all these factors play a role in shaping the delicate branches and patterns of each crystal dot. Think of them as tiny, frozen snowflakes caught mid-dance, their intricate forms preserved for a fleeting moment before they settle onto the surface, becoming part of the larger landscape. They accumulate, layer upon layer, forming the vast snowdrifts and sculpted ridges that define the Antarctic terrain. And what sculpts them? The wind, primarily. The relentless, biting winds that sweep across the continent, carving and shaping the snow into dunes and ripples, into sastrugi and snowdrifts. These formations aren't random. They're a record of the wind's passage, a frozen snapshot of atmospheric forces at work. Imagine the wind as an artist, using snow as its medium, creating sculptures on a scale that dwarfs human endeavors. And functional. These formations help to redistribute snow, to insulate the ground, and to create microclimates that support the surprisingly diverse range of life that clings to the Antarctic surface. Consider the sastrugi, those sharp, irregular ridges of snow that form parallel to the prevailing winds. They can be small, barely noticeable, or they can be massive, towering obstacles that challenge even the most experienced polar explorers. They're a testament to the power of the wind, a reminder that even in the most seemingly barren landscapes, there's a constant interplay of forces at work. And then there are the snowdrifts, those soft, undulating hills of accumulated snow that can blanket entire valleys and plains. They're shaped by the wind, too, of course, but also by the topography of the land, by the presence of obstacles that interrupt the flow of air and cause the snow to accumulate in certain areas. These drifts aren't just piles of snow. They're living, breathing formations, constantly changing and evolving as the wind continues to blow and the snow continues to fall. They can bury entire structures, completely transforming the landscape in a matter of hours. It's easy to overlook this artistry, to see only the white, the blankness, the perceived emptiness. But when you take the time to truly look, to truly observe, you begin to see the hidden beauty, the intricate details, the subtle nuances that make the Antarctic landscape so captivating. Each snow crystal, each wind-sculpted dune, each icy ridge tells a story of wind and temperature, of pressure and precipitation, of the forces that have shaped this continent for millennia. It's a story written in ice and snow, a story that's constantly being rewritten, constantly being updated. So, the next time you imagine Antarctica, don't just think of a frozen wasteland. Think of a vast, open-air museum filled with sculptures of ice and snow, each one a unique and beautiful work of art. Think of a place where the wind is the artist and the snow is its medium, creating masterpieces that are both ephemeral and enduring. Think of the hidden artistry on the surface. It's a reminder that beauty can be found in the most unexpected places, that even in the harshest of environments, even greater wonders await. It's a hint that this icy facade holds a secret, a promise of life and motion hidden deep within. The sculpted snow crystals are more than just pretty formations. They are an introduction an introduction to the hidden dynamics of Antarctica. But the true spectacle, the heart of this frozen world, remains unseen. Picture, if you will, the world beneath the mask of ice, a world unlike anything you've encountered. We've spoken of the surface, of the biting winds and seemingly endless expanse of white, but what lies beneath? What secrets are held captive under miles of solid ice? It's a question that has captivated scientists and explorers for decades. A question that challenges our very understanding of what's possible. The answer, surprisingly, is water. Liquid water beneath the crushing weight of the Antarctic ice sheet. A hidden network of rivers and lakes exists, an entire subterranean realm untouched by sunlight for millions of years. Imagine the darkness, the profound and absolute lack of light, a world where the only illumination comes from the Earth's own geothermal heat, a faint. This is a reality, a documented, mapped, and increasingly understood part of our planet. How can water exist in liquid form under such intense pressure and extreme cold? It seems paradoxical, almost impossible. The key lies in a combination of factors. Firstly, there's the immense pressure exerted by the overlying ice. This pressure actually lowers the freezing point of water, allowing it to remain liquid at temperatures slightly below 0 degrees Celsius. Secondly, there's geothermal heat emanating from the Earth's interior. This heat, though minimal, is enough to melt the ice at the base of the ice sheet, creating a thin layer of water that then flows, carving pathways through the bedrock over millennia. And thirdly, the ice itself acts as an incredible insulator, trapping the geothermal heat and preventing the subglacial water from freezing solid. It's a delicate balance, a complex interplay of forces that allows this hidden world to thrive. Think of it as a gigantic continent-sized pressure cooker, where the Earth's internal heat and the immense weight of the ice sheet create a unique environment where liquid water can exist. This water collects in vast subglacial lakes, some as large as hundreds of square kilometers, and flows through intricate networks of rivers, connecting these lakes and creating a hidden circulatory system for the entire continent. These subglacial rivers are not the raging torrents we might imagine. They are slow, deliberate streams moving at a glacial pace, often just a few centimeters per day. The ice in profound ways. They transport sediment, nutrients, and even microscopic life, connecting different parts of the subglacial environment and influencing the overall dynamics of the ice sheet. The water in these subglacial lakes is incredibly ancient, some of it having been isolated from the surface for millions of years. This makes these lakes time capsules, preserving a record of past climates, past environments, and even past life. They are like frozen museums, containing secrets that could unlock our understanding of Earth's history and the evolution of life itself. But perhaps the most astonishing aspect of this subglacial world is the potential for life to exist there. Despite the darkness, the cold, and the immense pressure, scientists believe that these subglacial lakes and rivers could harbor unique ecosystems adapted to these extreme conditions. Imagine microscopic organisms, bacteria and archaea, thriving in the absence of sunlight, feeding on chemicals released from the bedrock, forming the base of a food web that could support more complex life forms. It's a speculative idea, but one that is increasingly supported by scientific evidence. The discovery of these subglacial environments has revolutionized our understanding of Antarctica and the role it plays in the global climate system. These hidden rivers and lakes are not just isolated geological features. They are integral components of the Antarctic ecosystem, influencing the flow of ice, the transport of sediment, and the exchange of water between the ice sheet and the ocean. They are a critical link in the chain that connects the frozen continent to the rest of the planet. So, as you stand on the surface of Antarctica, imagine the world beneath your feet, the hidden rivers and lakes, the ancient water, and the potential for life. It's a world of darkness and mystery, a world of immense pressure and extreme cold, but also a world of incredible beauty and hidden potential. It's a reminder that even in the most seemingly barren places, life finds a way to persist, to adapt, and to thrive. And it's an invitation to look beyond the surface, to explore the hidden depths, and to discover the wonders that lie beneath. Beneath the mask of ice, a world unseen awaits. A world not of perpetual winter, but of liquid secrets held captive in the colds. Embrace. Here, where the sun's touch has never reached, lies a subterranean realm unlike any other on our planet. Imagine a network of rivers and lakes, a hidden hydrosphere carved into the bedrock beneath miles of solid ice. A place where water flows in perpetual darkness, a testament to the Earth's inner warmth and the surprising resilience of nature. These aren't sun-drenched rivers reflecting azure skies. These are shadowy veins threading through the frozen continent, their surfaces undisturbed by wind or weather. They are ancient arteries pulsing with a slow, deliberate rhythm, a heartbeat that has echoed beneath the ice for millions of years. No sunlight has ever kissed their waters. No photosynthesis sustains life as we know it on the surface. Instead, these rivers exist in a world defined by pressure, by the Earth's internal heat, and by the subtle chemistry of rock and ice. Picture, if you will, the sheer scale of it all. Rivers hundreds of kilometers long, carving pathways through valleys unseen by human eyes, lakes the size of small seas, vast reservoirs of ancient water, sealed off from the atmosphere for millennia. These are not mere puddles. They are complex ecosystems, cradling secrets of past climates and the faint echoes of life itself. The water within these subterranean rivers and lakes is incredibly pure, filtered through layers of ice and rock. Yet it's not sterile. It carries dissolved minerals, trace elements leached from the bedrock, forming a unique chemical soup. This cocktail of elements supports a hidden biosphere, a community of microbes adapted to thrive in the cold, dark, and nutrient-poor environment. These are the extremophiles, the survivors, the pioneers of an unseen world. They are the lifeblood of this subglacial realm, a testament to the incredible tenacity of life on Earth. Think of the sound, or rather, the absence of it. Above, the wind howls across the frozen plains, but down here, silence reigns supreme. Only the faint trickle of water, the almost imperceptible groan of the ice above, and perhaps the faint rustle of microbial life break the profound stillness. It's a silence that speaks volumes, a silence that holds the weight of millennia. These rivers and lakes are not static features. They are dynamic and ever-changing. The immense pressure of the overlying ice drives the water to flow, albeit Slowly, the Earth's internal heat provides a constant source of energy, melting the ice at the base and creating new pathways for the water to explore. The rivers themselves act as conduits, connecting the lakes and redistributing water and sediment. Across the subglacial landscape, the surfaces of these subglacial lakes are not smooth and still, like the lakes we know on the surface. The underside of the ice sheet above is uneven, creating a jagged, chaotic landscape. Icebergs, formed by the melting and refreezing of ice at the ice-water interface, float freely in the dark waters. These upside-down icebergs, sculpted by the currents and the chemical composition of the water, are a testament to the unique and bizarre environment that exists down below. Imagine the journey of a single drop of water in this subterranean realm. It might begin as a snowflake falling on the surface, slowly making its way down through the ice sheet over centuries. It might be ancient meltwater trapped beneath the ice millions of years ago. Regardless of its origin, it eventually joins a subglacial river carried along in the slow, deliberate current. It might spend decades, even centuries, circulating through the hidden waterways, dissolving minerals, supporting microbial life, and shaping the subglacial landscape. Eventually, this drop of water might reach the edge of the continent, where it flows into the ocean, carrying with it the secrets of the subglacial world. It mingles with the surface waters, influencing the ocean's salinity and temperature, and ultimately playing a role in the global climate. The subterranean realm is not isolated. It is an integral part of the Earth's interconnected systems. These subglacial rivers and lakes are more than just geological curiosities. They are vital components of the Antarctic ecosystem. They influence the stability of the ice sheet, affecting the rate at which it melts and contributes to sea level rise. They transport sediment and nutrients, shaping the seafloor and supporting marine life, and they provide a refuge for microbial life, offering a glimpse into the possibilities of life in extreme environments, perhaps even life beyond Earth. So, as you gaze upon a map of Antarctica, remember what lies beneath. Remember the hidden rivers, the ancient lakes, the slow, deliberate currents that shape this frozen continent. Remember the darkness, the pressure, the silence, and the surprising resilience of life. And let that knowledge inspire you to look beyond the surface, to question your assumptions, and to explore the hidden depths of our planet and ourselves. Because in the subterranean realm of Antarctica, the impossible becomes reality, and the secrets of the past are waiting to be discovered. It is a testament to the power of water and life to persist in the face of adversity. A chilling but beautiful world thriving in darkness. But these aren't simply trickles. They are slow, deliberate streams. Imagine honey, viscous and patient, carving its way across a surface over eons. That's a glimpse into the tempo of these subglacial rivers. They're not rushing rapids or roaring waterfalls. They're glacial arteries, moving at a pace dictated by the immense forces at play, warmed, almost imperceptibly, by the Earth's geothermal heart and the crushing weight of the ice sheet above. They exist in a delicate equilibrium. The ice presses down, creating immense pressure, which, surprisingly, lowers the freezing point of water. Combined with the faint warmth rising from the bedrock, this allows water to persist in liquid form, even under what we would normally consider impossibly frigid conditions. Think of it as a geological pressure cooker. a system finely tuned to maintain this liquid existence. And this liquid existence is key, eroding and shaping the landscape with unimaginable patience. They act as subterranean sculptors, revealing valleys and canyons hidden for millennia. They thread their way through the continent's underbelly, connecting subglacial lakes and acting as conduits for sediment and nutrients. These rivers are not just geographical features. They are active agents of change, slowly but surely reshaping the very foundation of Antarctica. They control the movement of ice sheets, influencing their stability and their eventual contribution to global sea levels. A seemingly insignificant stream can have a profound impact on the entire continent, and indeed the entire planet. Consider the network of interconnected waterways that exists beneath the West Antarctic ice sheet. This is a complex system of channels and lakes, all linked together in a constantly evolving hydrological dance. These waterways lubricate the base of the ice sheet, allowing it to flow more easily towards the sea. Changes in the volume and flow of these rivers can therefore accelerate or decelerate the movement of the ice, with potentially dramatic consequences. For coastal communities around the world, it's a delicate balancing act, a complex interplay of ice, water, and bedrock, all working together in a system that we are only beginning to understand. And the more we learn, the more we appreciate the importance of these hidden rivers in shaping the Antarctic landscape and influencing the global climate. But these subglacial rivers are not just about geology and glaciology. They are also about biology. They transport nutrients and organic matter from the land to the sea, providing a vital source of sustenance for marine ecosystems. They may also harbor unique microbial communities, adapted to life in the cold, dark, and nutrient-poor environment beneath the ice. Imagine bacteria and archaea thriving in the absence of sunlight, utilizing chemosynthesis to obtain energy from chemical compounds dissolved in the water. These microscopic organisms could hold valuable clues about the origins of life and the potential for life to exist in other extreme environments, both on Earth and beyond. The slow, deliberate streams of Antarctica are not just rivers. They are ecosystems, miniature worlds hidden beneath a frozen continent. They are testaments to the resilience of life, its ability to adapt and thrive in the most unlikely of places. They are reminders that even in the darkness, there is always the potential for life to flourish. So, next time you picture Antarctica, don't just imagine a frozen wasteland. Picture the slow, deliberate streams flowing beneath the ice, carving their way through the bedrock, connecting lakes and ecosystems, and shaping the future of the continent. Picture the hidden world teeming with life, a testament to the power of water and the resilience of nature. And remember that even the most seemingly barren landscapes can hold secrets of profound beauty and significance. These secrets are waiting to be uncovered, waiting to be explored, waiting to change our understanding of the world and our place within it. These slow, deliberate streams are not just part of Antarctica. They are part of us, a reminder of the hidden depths and the enduring power of life that exists within us all. But now, let's descend even deeper. Let's journey further beneath the mask of ice, past the flowing rivers, into the heart of Antarctica's hidden hydrological network. We're heading towards the subglacial lakes, These are not mere puddles hidden beneath the ice. They are vast, sprawling bodies of water, some larger than well-known above-ground lakes. Lake Vostok, the crown jewel of these subterranean reservoirs, stretches for over 150 miles long and 30 miles wide. To give you some context, that's roughly the size of Lake Ontario, one of the Great Lakes of North America. Imagine an entire Great Lake, hidden, utterly isolated, beneath miles of solid ice. These lakes aren't just geographically significant, they are scientifically invaluable. Imagine a time capsule sealed off from the Earth's atmosphere for millions of years. The water within these lakes has been isolated from the surface world for potentially 15 to 20 million years. That's longer than humans have even existed. This isolation makes them unique repositories of ancient information, holding within their depths clues about past climates, geological processes, and perhaps most intriguingly, unique forms of life. Think about what that means. We're talking about water that hasn't interacted with our atmosphere since the Pliocene epoch, a time when the Earth was significantly warmer and the Arctic was possibly ice-free. Trapped within this water are dissolved gases, organic matter, and potentially even microorganisms that have evolved in complete darkness, under immense pressure, and in near-freezing temperatures. These lakes are like pristine laboratories, offering a window into a world that existed long before our own. The pressure at the bottom of Lake Vostok is immense, around 350 times the atmospheric pressure at sea level. That's like being at a depth of over 11,000 feet in the ocean, yet the water remains liquid. This is due to a combination of factors: the geothermal heat rising from the Earth's interior and the immense pressure exerted by the overlying ice, which lowers the freezing point of water. This delicate balance of heat and pressure creates a unique environment where liquid water can persist despite the extreme cold. The ice sheet above Lake Vostok isn't static either. It's constantly moving and deforming under its own weight, a process that creates a layer of accretion ice at the bottom of the ice sheet where it meets the lake. This accretion ice forms as the water from the lake freezes onto the bottom of the glacier, adding a layer of ice to the ice sheet. As this process occurs, materials and microorganisms present in the lake get trapped within the newly formed ice, creating a frozen record of the lake's contents. Think of it as a naturally occurring ice core sample, constantly being created and added to. Scientists are incredibly interested in studying this accretion ice because it offers a relatively accessible way to sample the contents of the lake without directly drilling into the lake itself. By analyzing the ice, they can gain insights into the chemical composition of the water, the types of microorganisms present, and the geological history of the region. This is crucial because drilling directly into the lake carries a significant risk of contamination, which could compromise the integrity of the pristine ecosystem. Beyond the scientific value, imagine the sheer wonder of discovering such a place. A vast, ancient lake, hidden beneath miles of ice, teeming with potentially unique forms of life. It's a discovery that forces us to reconsider our understanding of life's limits and the potential for life to exist in even the most extreme environments. It's a reminder that our planet is full of surprises, and that even in the most seemingly barren places, there are hidden worlds waiting to be explored. These subglacial lakes and Lake Vostok in particular, are not just geological formations or scientific curiosities. They are portals to the past, potential incubators of unique life forms, and reminders of the hidden complexities of our planet. They challenge our assumptions, inspire our curiosity, and invite us to look beyond the surface, to appreciate the hidden wonders that lie beneath. But these lakes and rivers aren't just static puddles, interesting though they may be. They're dynamic ecosystems, teeming, yes, teeming with life. A life adapted to crushing pressure, perpetual darkness, and near-freezing temperatures. And within that life, within the water itself, lies a treasure trove of ancient secrets. Think of it, water that hasn't seen sunlight for millions of years. Water that predates human civilization, predates even the earliest primates. It's a time capsule, a liquid archive holding within it dissolved gases, organic molecules, and most remarkably, living organisms. These aren't the complex, multicellular creatures you might find in a sunlit lake. These are microorganisms, bacteria and archaea, single-celled entities that have adapted to thrive in this extreme environment. They're the descendants of life forms that existed on Earth billions of years ago, offering a glimpse into the planet's primordial past. Imagine the evolutionary journey they've undertaken, the adaptations they've developed to survive and flourish in this alien world. And what are they eating? Sunlight is out of the question. Instead, they rely on chemosynthesis, extracting energy from chemical compounds dissolved in the water. These compounds might come from the slow weathering of the bedrock, from the Earth's geothermal activity, or even from the decay of organic matter that has accumulated over millennia. They represent an entire food web, a complete and self-contained ecosystem existing entirely independent of the surface world. It's like discovering a hidden city beneath the ice, a bustling metropolis teeming with activity, all powered by a completely different energy source. But the secrets don't stop there. The water also holds clues about Earth's past climate. As ice freezes and melts, it traps air bubbles, providing a snapshot of the atmosphere at the time the ice was formed. In these subglacial lakes and rivers, this process happens over vast timescales, accumulating layer upon layer of climate data, going back hundreds of thousands, even millions of years. By analyzing the composition of these trapped gases, scientists can reconstruct past temperatures, atmospheric carbon dioxide levels, and other key climate indicators. It's like reading the rings of a tree, but on a scale that encompasses entire geological epochs. Furthermore, the sediments at the bottom of these lakes hold even more secrets. These sediments are a record of everything that has washed into the lake over millions of years. Dust, pollen, volcanic ash, even the remains of long-extinct organisms. By studying these layers, scientists can piece together a detailed picture of the changing environment in Antarctica, from its ancient forests to its current frozen state. It's like digging through the layers of an archaeological site, uncovering the artifacts of a lost civilization, each layer revealing a different chapter in the continent's history. Think of the implications. Understanding past climate changes can help us predict future climate changes, allowing us to better prepare for the challenges of a warming world. By studying the microbial ecosystems in these subglacial lakes, we can learn about the limits of life on Earth, and perhaps even gain insights into the possibility of life on other planets. These hidden waterways are not just interesting geological features, they are a vital resource for scientific discovery, offering clues to some of the most pressing questions facing humanity. And it's not just about the big picture. Questions of climate change and extraterrestrial life. These subglacial environments also offer a unique opportunity to study evolution in isolation, because these ecosystems have been sealed off from the surface world for so long. The organisms within them have evolved in unique ways, adapting to the specific conditions of their environment. By studying these adaptations, we can gain a deeper understanding of the mechanisms of evolution and how life can thrive in even the most extreme conditions. They are living laboratories, offering insights into the fundamental principles of biology. The more we learn about these ancient secrets, the more we realize how much we still don't know. The subglacial world is a vast and unexplored frontier, full of mysteries waiting to be uncovered. Each new discovery raises new questions, challenging our assumptions and expanding our understanding of the planet. It is a reminder that even in the 21st century, there are still places on Earth that remain largely unknown, waiting to be explored. And in that exploration, perhaps, we will discover not only new scientific insights, but also a deeper appreciation for the resilience and adaptability of life on Earth, a testament to life's enduring ability to carve a niche, to thrive, to adapt and conquer even the darkest, coldest, and most isolated environments. The secrets held within the ice are not just about the past, they are also about the future. But these hidden waterways aren't just geological curiosities, something interesting to file away in the annals of science. They form a vital, dynamic ecosystem, playing a far-reaching role in influencing not only the behavior of the Antarctic ice itself, but also, surprisingly, the global climate patterns that affect us all. Think of it like this: the subglacial water acts as a kind of lubricant, allowing the ice sheets above to slide more easily over the bedrock, and its movement towards the ocean would be significantly slower. This might sound like a good thing, preventing sea levels from rising, but the reality is far more complex. The rate at which the ice flows into the ocean, a process known as ice discharge, is a critical factor in regulating global sea levels. If the flow is too slow, the ice sheet can thicken and become unstable, potentially leading to sudden and catastrophic collapses. If the flow is too fast, it contributes to a gradual but steady rise in sea levels, threatening coastal communities around the world. The subglacial waterways, therefore, act as a delicate regulator, influencing the speed and stability of the ice sheet and, by extension, the balance of our planet's oceans. They are the unsung heroes of climate stability, working tirelessly beneath the ice to maintain a delicate equilibrium. But their influence doesn't stop there. And nutrients, as they flow beneath the ice, they erode the bedrock, carrying tiny particles of rock and minerals along with them. When this water eventually reaches the ocean, it releases these sediments, providing essential nutrients for marine life. These nutrients fuel the growth of phytoplankton, microscopic plants that form the base of the marine food web. Phytoplankton, in turn, are consumed by larger organisms, supporting a vast and diverse ecosystem that stretches from the Antarctic coast to the far reaches of the global ocean. And perhaps most importantly, phytoplankton absorb vast quantities of carbon dioxide from the atmosphere, helping to regulate the Earth's climate in this way. The subglacial waterways of Antarctica are directly linked to the health and productivity of the world's oceans and the stability of our global climate. They are a crucial component of a complex and interconnected system, a system that is only now beginning to be fully understood. What's even more fascinating is the potential for these subglacial environments to harbor unique ecosystems of their own, completely isolated from sunlight and the surface world. These hidden lakes and rivers may contain microbial life forms that have adapted to survive in extreme conditions. These organisms, known as extropophiles, could hold valuable clues about the origins of life on Earth and the potential for life to exist on other planets. Imagine a world where life thrives in complete darkness, powered by chemical energy derived from the rocks and minerals around it. A world where organisms have evolved to withstand extreme pressures, temperatures, and nutrient limitations. It's a world that challenges our assumptions about the limits of life and expands our understanding of the universe. Exploring these subglacial ecosystems is a challenging but incredibly rewarding endeavor. Scientists have developed sophisticated techniques for drilling through miles of ice and accessing these hidden environments without contaminating them, analyzed in the lab to identify the types of organisms that live there and to understand their metabolic processes. The discoveries that have been made so far are truly remarkable. Scientists have found evidence of diverse microbial communities, including bacteria, archaea, and even small invertebrates, thriving in the subglacial lakes and rivers. They are actively metabolizing, reproducing, and interacting with their environment. The study of these subglacial ecosystems is not just about understanding the biology of Antarctica. It's about understanding the fundamental principles of life and the potential for life to exist in extreme environments throughout the universe. It's a reminder that life is incredibly resilient, adaptable, and resourceful, capable of finding a way to thrive even in the most challenging conditions. So, as you contemplate the vast expanse of the Antarctic ice sheet, remember the hidden world that lies beneath. Remember the flowing rivers, the ancient lakes, and the thriving ecosystems that are shaping the continent and influencing the planet. And remember that even in the darkest, coldest, and most seemingly desolate places, life finds a way to persist, to adapt, and to flourish. The subglacial waterways of Antarctica are a testament to the power of water, the resilience of life, and the interconnectedness of our planet. They are a hidden treasure waiting to be discovered and explored, a source of wonder and inspiration for generations to come. Scientists are explorers drawn to the edges of the known world. And in Antarctica, the new frontier isn't just about venturing to the continent, but delving beneath it, mapping the impossible. That's what these researchers are doing. They're building a picture of a world we can't directly see, a world hidden beneath miles of solid ice. Imagine the challenge. You can't just lower a camera into the darkness. This isn't like exploring the deep ocean where light struggles to penetrate. Only the crushing pressure of ice above and the faint warmth radiating from the earth below. So, how do they do it? How do they peer through a frozen veil that's thicker than the Grand Canyon is deep? Technology and painstaking analysis. Radar, for instance, plays a crucial role. Imagine sending pulses of radio waves down through the ice, like sonar through the sea. These waves encounter different densities, different layers of ice and rock, and bounce back, carrying information about what lies beneath. It's like shouting into a canyon and listening to the echoes. The shape of the canyon, the texture of its walls, all influence the way the sound returns. Similarly, the radar echoes reveal the topography of the subglacial landscape, the contours of hidden mountains, the paths of buried rivers, the vast expanses of subglacial lakes. But radar isn't the only tool in their arsenal. Seismic surveys offer another crucial perspective. Think of it as creating tiny, controlled earthquakes. Scientists use specialized equipment to generate vibrations at the surface, then carefully measure how those vibrations travel through the ice and the bedrock below. Just as a doctor uses an ultrasound to see inside your body, seismologists use these vibrations to create images of the Earth's interior. The speed and direction of the seismic waves change depending on the type of material they encounter. Ice, rock, water. Each material has a unique seismic signature. By analyzing these signatures, scientists can identify different features of the subglacial landscape with incredible precision. They can distinguish between solid bedrock and water-saturated sediments, map the boundaries of subglacial lakes, and even detect the presence of geothermal hotspots, areas where the Earth's internal heat is melting the ice from below. The data, collected from radar and seismic surveys, is incredibly complex, requiring sophisticated computer models and years of dedicated research to interpret. It's like piecing together a giant jigsaw puzzle with millions of pieces, many of which are missing or distorted. But slowly, painstakingly, the picture is emerging. We are beginning to see the outlines of a vast, interconnected network of rivers and lakes, a hidden plumbing system that underlies the entire continent. We are discovering that the ice itself is not a monolithic block, but a complex, dynamic system, constantly interacting with the water beneath. And as we map this hidden world, we are also learning more about the past. The sediments beneath the ice hold clues to ancient climates, to the evolution of life, to the dramatic shifts that have shaped our planet over millions of years. Each grain of sand, each fossilized microorganism, each dissolved chemical compound tells a story. These stories are like chapters in a vast, forgotten history book, waiting to be deciphered. Consider the implications. This isn't just about understanding Antarctica. It's about understanding our planet as a whole. The subglacial water system plays a critical role in regulating the flow of ice into the ocean, influencing sea levels and global climate patterns. By studying this hidden world, we can gain a better understanding of how the Earth system works and how it might respond to future changes. And perhaps most importantly, the exploration of Antarctica's subglacial world challenges our assumptions about what is possible. It reminds us that even in the most extreme environments, even in the deepest darkness, there is still much to discover, much to learn, and much to marvel at. It is a true testament to human ingenuity and our unwavering curiosity about the world around us. It's a bold reminder that the pursuit of knowledge knows no bounds, even when those bounds are defined by miles of solid ice. Beneath the immense weight of the Antarctic ice sheet, lies a world shrouded in perpetual darkness. We can't simply drill down and peer into this hidden realm. The ice is too thick, the pressure too immense. So how do scientists even begin to understand what lies beneath this frozen continent? The answer lies in a couple of ingenious technologies: radar and seismic surveys. Imagine you're trying to map a vast underground cave system without actually entering it. You wouldn't blindly wander around in the dark. You'd need a way to see through the rock. That's essentially what scientists are doing in Antarctica, using radar and seismic waves as their eyes and ears. Let's start with radar, specifically ice-penetrating radar. This technology works by emitting radio waves that travel through the ice. When these waves encounter a change in density, say the boundary between ice and water or ice and rock, a portion of the signal is reflected back to the surface. By carefully analyzing the strength and timing of these reflections, scientists can create a detailed map of the subglacial landscape. Think of it like shouting into a canyon and listening to the echo. The longer it takes for the echo to return, the farther away the canyon wall must be. Similarly, the longer it takes for the radar signal to bounce back, the deeper the feature it encountered. The strength of the echo can also tell you something about the material it bounced off of. A strong, clear echo might indicate a smooth, flat surface, like the top of a subglacial lake. A weaker, more diffuse echo might suggest a rough, uneven surface, like the bedrock beneath the ice. Radar surveys are typically conducted using aircraft, which fly in a grid pattern over the Antarctic ice sheet. These planes are equipped with specialized radar equipment that can transmit and receive the radio waves. As the plane flies, it constantly emits pulses of radar energy, recording the returning signals. This data is then processed using sophisticated computer algorithms to create three-dimensional maps of the subglacial topography. It's like creating a virtual X-ray of the Antarctic continent, revealing the hidden world beneath the ice. And it's through this process that we've discovered the vast network of subglacial rivers and lakes, the towering mountains and deep valleys that lie buried beneath the ice. But radar isn't the only tool in the scientists' arsenal. Seismic surveys provide another powerful way to probe the depths of Antarctica. Seismic surveys rely on sound waves rather than radio waves. In this technique, scientists generate vibrations either through small explosions or using heavy vibrating trucks if they can traverse the terrain, and then record the resulting seismic waves as they travel through the ice and underlying rock. Just like radar waves, seismic waves reflect and refract when they encounter changes in density or composition. By carefully analyzing the arrival times and amplitudes of these waves at different locations, scientists can infer the structure of the subsurface. Different materials transmit seismic waves at different speeds. Ice, water, and rock all have distinct seismic signatures. This allows scientists to differentiate between these materials and to create detailed models of the subglacial geology. Imagine tapping on a watermelon. The sound it makes can tell you something about its ripeness and internal structure. Similarly, the way seismic waves travel through the ice can reveal the presence of hidden water bodies, the composition of the bedrock, and even the thickness of the sediment layers. Seismic surveys are often used in conjunction with radar surveys to provide a more complete picture of the subglacial environment. Radar is excellent at mapping the boundaries between ice, water, and rock, while seismic surveys are better at characterizing the properties of the materials themselves. By combining these two techniques, scientists can gain a comprehensive understanding of the hidden world beneath the Antarctic ice. These surveys aren't without their challenges. The extreme cold, the remoteness of the location, and the sheer scale of the Antarctic continent all make these measurements difficult to acquire. Data processing can also be a complex and time-consuming task. And of course, there's the ever-present challenge of access. Getting equipment and personnel to remote locations in Antarctica requires careful planning and logistical support. Researchers often rely on specialized vehicles, like snowmobiles and tracked vehicles, to traverse the vast distances and reach their study sites. Airplanes and helicopters are also used to transport equipment and personnel to more remote locations. Despite these challenges, radar and seismic surveys have revolutionized our understanding of Antarctica. They've revealed a hidden world of rivers, lakes, and mountains that was once thought to be impossible, and they've provided valuable insights into the dynamics of the Antarctic ice sheet, the history of the continent, and the potential impacts of climate change. These technologies aren't just about mapping a hidden landscape. They're about understanding the intricate processes that shape our planet. They're about unlocking the secrets of the past and predicting the future. And they're a testament to human ingenuity and our relentless pursuit of knowledge, even in the most extreme and challenging environments on Earth. So, the next time you see an image of Antarctica's seemingly endless white expanse, remember that beneath the surface, a hidden world awaits, revealed through the power of radar and seismic whispers. But it's not just about scientific discovery. The exploration of Antarctica's subglacial world transcends mere data collection. It forces us to reconsider our fundamental perceptions of life itself. We often confine life to a narrow set of parameters: sunlight, readily available nutrients, a relatively stable environment. Antarctica's hidden world throws those definitions into disarray. Imagine ecosystems thriving in perpetual darkness, sustained by chemical energy from rocks, in waters insulated from the atmospheric world above for millions of years. Microbes, tiny but tenacious, clinging to existence in the face of crushing pressure and near-freezing temperatures. These aren't just biological anomalies. They are powerful testaments to the adaptability and resilience of life, proving that its boundaries are far more expansive than we previously imagined. It begs the question, if life can flourish in such an extreme environment, what other possibilities await discovery, both on Earth and beyond? Could similar ecosystems exist on icy moons like Europa or Enceladus, hidden beneath their own frozen shells? Antarctica becomes a proving ground, a natural laboratory for understanding the potential for life to arise and persist in the most unexpected places. And it's not just about the presence of life, but the kind of life. These subglacial ecosystems offer a unique window into the early evolution of life on Earth, potentially harboring microbial communities that have remained largely unchanged for millions of years. Studying these organisms could unlock profound insights into the origins of life and the processes that have shaped our planet. They are a living fossil record, a testament to the enduring power of adaptation and the interconnectedness of all living things. Think about it. Organisms living in complete isolation, evolving independently for eons. Their genetic makeup, their metabolic processes, their very existence challenges our understanding of what it means to be alive. They force us to expand our definition of habitability, to consider the possibility that life can find a way, even in the face of seemingly insurmountable odds. But beyond the scientific implications, the exploration of Antarctica's subglacial world also carries a profound philosophical weight. It reminds us of the fragility and interconnectedness of our planet. The hidden waterways beneath the ice are not isolated systems. They are intimately linked to the global climate, influencing the flow of ice, the distribution of nutrients, and the stability of sea levels. What happens beneath the ice has ripple effects that extend far beyond Antarctica's shores. The melting of ice sheets, driven by climate change, can release vast quantities of fresh water into the oceans, disrupting ocean currents and impacting weather patterns worldwide. Understanding the dynamics of these subglacial systems is therefore crucial for predicting and mitigating the effects of climate change. In a way, Antarctica serves as a mirror, reflecting back to us our own vulnerabilities and responsibilities. It reminds us that even the most seemingly remote and inhospitable places on Earth are inextricably linked to our own fate. The choices we make today will determine the future of Antarctica, and in turn, the future of the planet. So, as you contemplate the hidden world beneath the ice, consider also the hidden depths within yourself. Just as subglacial rivers carve pathways through the bedrock, shaping the landscape over millennia, our own experiences, both seen and unseen, shape who we are. Just as life finds a way to thrive in the darkness, we too possess a remarkable capacity for resilience, for adapting to challenges, and for finding beauty in the face of adversity. Let the exploration of Antarctica inspire you to look beyond the surface, to question your assumptions, and to embrace the unknown. For it is in the depths of the unknown that we often discover the greatest truths, both about the world around us and about ourselves. And to reflect on the power of water, even as ice, to sculpt, preserve, and facilitate life on our planet. Despite all adversities, the exploration of Antarctica is not just a journey to the bottom of the world. It's a journey into the heart of what it means to be human, to be alive, and to be connected to something larger than ourselves. It's a testament to the enduring power of curiosity, the resilience of life, and the boundless potential for discovery that lies hidden beneath the surface. Life thrives. Even in the most extreme environment, life finds a way. This isn't just a hopeful sentiment. It's a profound observation, one that the hidden world of Antarctica throws into sharp relief. We've talked about ancient lakes, about rivers flowing in perpetual darkness. Now, consider what might live in those places, what secrets those waters hold. It challenges our very definition of what's possible, doesn't it? We picture sunlight, warmth, the familiar rhythms of seasons, dictating the ebb and flow of life. But down there, miles beneath the ice, those rules don't apply. It's a world of constant cold, immense pressure, and complete darkness, yet life persists. Think of it like this. The power of water, in all its forms, is the keystone. The water molecules themselves, forged in the heart of collapsing stars, carry the potential for life. Down there, shielded from cosmic radiation and the vagaries of surface conditions, that potential is realized in surprising ways. Scientists have discovered microbial ecosystems in these subglacial lakes and rivers. Bacteria, archaea, even simple multicellular organisms adapted to conditions we would consider utterly inhospitable. They are extremophiles, thriving in environments that would instantly kill most surface life. They derive energy from chemical reactions, from the slow decay of minerals, from the very rock around them. They've built entire ecosystems based on chemosynthesis instead of photosynthesis. These organisms are incredibly ancient, representing lineages that may have evolved in isolation for millions of years. They are living relics, time capsules of life on Earth from a vastly different era. Studying them provides invaluable insights into the origins of life, the limits of adaptation, and the potential for life to exist in other extreme environments, perhaps even on other planets. It's a humbling thought, isn't it, that life, in its simplest forms, can be so resilient, so resourceful, so utterly determined to persist. It forces us to reconsider our own place in the universe, our own assumptions about what is and isn't possible. And it all happens unseen, unheard, beneath a continent of ice, a hidden world, a silent testament to the power of adaptation. It reminds us that life isn't always about grand gestures or dramatic displays. Sometimes it's about the slow, steady persistence of tiny organisms in the face of overwhelming odds. Imagine the adaptations necessary to survive in such a place. Metabolic pathways finely tuned to extract energy from the smallest possible sources. Cellular structures that can withstand crushing pressure. Repair mechanisms that can cope with the constant damage caused by extreme cold. These are not just biological curiosities. They are masterpieces of evolutionary engineering, and the implications extend beyond just the scientific realm. These extremophiles offer a lesson in resilience, in the ability to thrive even in the darkest of times. They show us that even when all seems lost, when the environment is at its most hostile, life can still find a way. It's a powerful metaphor for our own struggles, our own challenges, our own capacity to adapt and overcome adversity. The Antarctic subglacial world, then, is not just a place of scientific discovery. It's a source of inspiration, a reminder of the enduring power of life and the boundless potential of the natural world. It is a call to look beyond the surface, to challenge our assumptions, and to appreciate the hidden wonders that surround us, even in the most unexpected places. As we continue to explore this hidden realm, we'll undoubtedly uncover even more astonishing secrets, more examples of life thriving in the face of adversity. And with each new discovery, we'll gain a deeper understanding, not only of Antarctica, but also of ourselves, of our own capacity for resilience, and of the enduring power of life to find a way, no matter the odds. So, as you consider the vast, frozen landscape of Antarctica, remember the tiny organisms that are quietly thriving beneath the ice. Remember their resilience, their adaptability, their unwavering determination to persist, and let that knowledge inspire you to embrace your own challenges, to find your own hidden strengths, and to never give up on the possibility of life, even in the darkest of times. Because even in the most extreme environment, life finds a way. The power of water sustains it, evolution shapes it, and the darkness hides it, waiting to be revealed. Water, the lifeblood of our planet, flowing through veins both visible and unseen. We think of it as a surface phenomenon, the oceans, rivers, and lakes that paint our world in shades of blue. But water's true power lies in its ability to persist, to adapt, to carve its own path, even in the face of overwhelming adversity. And nowhere is this more evident than in the frozen kingdom of Antarctica. Imagine a world locked in perpetual winter, a landscape buried beneath miles of solid ice. Logic dictates that such a place should be devoid of liquid water, a frozen wasteland incapable of supporting life. But logic, it seems, is often defied in the face of nature's ingenuity. Beneath the icy mask of Antarctica lies a hidden world, a network of subterranean rivers and lakes that defy the very definition of extreme environment. These are not mere geological curiosities. They are thriving ecosystems, sustained by the power of water to adapt and endure. The secret to this survival lies in a delicate balance of factors. The Earth's own geothermal heat, radiating from the planet's core, provides a subtle but crucial source of warmth. This heat, combined with the immense pressure exerted by the overlying ice, lowers the melting point of water just enough to allow it to exist in liquid form. Think of the sheer weight of miles of ice pressing down upon the bedrock. This pressure, unimaginable to those of us on the surface, acts like a constant embrace, squeezing the earth and coaxing water into existence. It's a testament to the power of physics, a demonstration of how seemingly immutable laws can be bent and shaped to create pockets of possibility in the most unlikely of places. But it's not just about survival, it's about adaptation. The organisms that inhabit these subglacial environments have evolved unique strategies to thrive in the cold, dark, and nutrient-poor conditions. They are extremophiles, masters of adaptation, pushing the boundaries of what we thought was possible for life on Earth. Imagine tiny microbes, bacteria and archaea, living in perpetual darkness, relying on chemical energy derived from the rocks and minerals around them. They are the foundation of a hidden food web, a self-sustaining ecosystem that has existed for millions of years, completely isolated from the surface world. These organisms are not just surviving, they are flourishing. They are creating their own unique ecosystems, teeming with life, adapted to the extreme conditions. They offer a glimpse into the potential for life to exist in other extreme environments, both on Earth and beyond. The subglacial waterways also play a critical role in shaping the Antarctic landscape. These hidden rivers act as conduits, transporting water, sediment, and nutrients from one part of the continent to another. They influence the flow of ice, the stability of ice sheets, and the overall climate of the region. Think of these rivers as a hidden circulatory system, a network of veins and arteries that keeps the continent alive. They connect distant lakes, redistribute heat, and transport vital resources, ensuring the long-term health and stability of the Antarctic ecosystem. Scientists are only beginning to understand the full extent of this subglacial network through the use of radar, seismic surveys, and sophisticated drilling techniques. They are mapping these hidden waterways, uncovering new lakes, and studying the unique life forms that inhabit them. Each new discovery is a revelation, a testament to the power of water to create and sustain life in the most extreme environments. These discoveries challenge our assumptions about the limits of life and inspire us to look beyond the surface, to explore the hidden wonders that lie beneath. But the power of water extends beyond mere survival and adaptation. It also serves as a powerful force for change. The subglacial rivers and lakes can lubricate the base of the ice sheets, accelerating their flow towards the ocean. This process can have significant implications for sea level rise and global climate change. Imagine the immense power of these hidden waterways, subtly but inexorably shaping the future of our planet. They are a reminder that even in the most seemingly remote and isolated environments, everything is interconnected, and even the smallest changes can have far-reaching consequences. The exploration of Antarctica's subglacial world is not just a scientific endeavor. It is a journey into the heart of our planet, a quest to understand the forces that shape our world and the potential for life to thrive in the most unexpected places. It's a story of resilience, adaptation, and the enduring power of water to shape the world around us. A story that reminds us of the interconnectedness of all things and the importance of protecting our planet's precious resources. So, the next time you see a glass of water, remember the hidden rivers and lakes of Antarctica, the life that thrives in perpetual darkness, and the power of water to persist, to adapt, and to shape the world around us. Let it serve as a reminder of the hidden potential that lies beneath the surface, both in the world around us and within ourselves. The world above may be silent, but beneath your feet the ice is alive with whispers, not the kind you can hear with your ears attuned to the open air, but a deep, resonating symphony felt in the very bones. It groans, it creaks, it shifts with a weight that has been accumulating for millennia, a slow, deliberate dance performed. In the chilling dark, imagine a colossal, frozen orchestra, its instruments crafted from glacial ice and played by the unseen hands of pressure and time. This isn't a random cacophony, it's a language, a complex and ancient conversation echoing through the frozen depths, a testament to the dynamic forces at play within this seemingly static landscape. Picture yourself standing on the surface, the crisp, cold air biting at your exposed skin. You feel the stillness, the almost oppressive quiet. But now, imagine you possess the ability to perceive the subtle vibrations, the low-frequency rumbles that travel through the ice. You are, in essence, a giant ear pressed against the Earth's skin, listening intently to the murmurs emanating from the hidden depths. You're not just passively experiencing the surface. You're actively trying to decipher the secrets held captive within the ice, to understand the forces shaping this frozen world. What stories are buried there? What echoes of ancient climates, of forgotten life, still resonate within its crystalline structure? Each crack, each groan, each subtle shift is a syllable in this frozen language, a clue to understanding the past, the present, and perhaps even the future of this enigmatic continent. Imagine the weight of millennia pressing down, compacting layers of snow and ice, preserving within them tiny bubbles of ancient air, flecks of pollen from long-vanished plants, microscopic organisms frozen in time. The ice itself becomes a living archive, a vast library holding the Earth's secrets. And it's not just the weight of the ice itself that speaks. The interplay of temperature, pressure, and the slow, relentless flow of water beneath the ice sheet all contribute to this sonic tapestry. Subglacial rivers carve pathways through the bedrock, their currents creating subtle vibrations that travel upwards through the ice. The grinding of ice against rock, the fracturing of ice shelves calving into the sea, the expansion and contraction of the ice in response to seasonal changes, all these events create a complex and ever-changing soundscape. Think of it as a geological symphony, a composition written in ice and water, played out over eons. Each instrument has its own unique voice, its own distinct timbre. The deep groans of the ice sheet are like the sustained notes of a massive pipe organ, resonating with immense power. The sharp cracks and pops of fracturing ice are like the staccato bursts of percussion instruments, punctuating the overall melody. The subtle rushing sounds of subglacial rivers are like the gentle flow of strings, adding a layer of texture and depth to the composition. But to truly understand this language, you need to be more than just a passive listener. You need to be an interpreter, a translator, capable of decoding the complex signals and extracting their hidden meaning. This is precisely what scientists are striving to do. They aren't just seeing the ice. They're listening to it with unwavering attention, developing the tools and techniques needed to understand its subtle and complex language. They use sophisticated instruments, like acoustic sensors and radar, to probe the depths, bouncing signals off the layers of ice and rock, carefully analyzing the returning echoes. It's like using a giant stethoscope to listen to the heartbeat of the Earth, to diagnose its ailments, and to understand its inner workings. These sensors can detect even the faintest vibrations, the smallest shifts in the ice, providing valuable insights into its behavior and its history. Imagine the challenges involved in this endeavor, the sheer scale of the ice sheet, the extreme environmental conditions, and the remoteness of the location, all present formidable obstacles. But scientists are undeterred, driven by a deep curiosity and a passion to unravel the mysteries hidden beneath the ice. They are painstakingly piecing together the puzzle, one acoustic signal at a time, translating the echoes into maps of the hidden world beneath, revealing the intricate network of rivers, lakes, and geological formations that lie hidden beneath the frozen surface. They are creating detailed models of ice sheet dynamics, predicting how the ice will respond to climate change and how its melting will impact sea levels around the world. They are discovering new species of microorganisms thriving in the subglacial lakes, organisms that have been isolated from the surface world for millions of years, offering clues to the origins of life and the potential for life in other extreme environments. They are uncovering valuable information about past climates, reconstructing ancient environments, and gaining a deeper understanding of the Earth's climate history. So, the next time you think of Antarctica as a silent, frozen wasteland, remember the whispers beneath your feet. Remember the groans, the creaks, the subtle shifts of the ice, the ancient conversations echoing through the frozen depths. Listen closely, and you might just begin to understand the secrets that lie hidden beneath the mask of ice, the stories waiting to be told. For in the heart of this frozen continent, there is a symphony playing, a language waiting to be deciphered, and a world of wonders waiting to be discovered. Beneath your feet, the ice isn't just a solid block, it's a symphony of subtle sounds, a language of ice spoken in groans that resonate through the miles, in creaks that echo the pressure of unseen forces, in shifts that whisper of movements both ancient and relentless. It's a conversation happening on a scale that dwarfs our own, a dialogue between ice, rock, and the hidden waters below. Think of it. Each creak, each groan is a word. Each shift, each subtle vibration, a sentence in a story written over millennia. The ice isn't just passively sitting there. It's reacting, adjusting, responding to the forces acting upon it. It's telling us about its history, its present state, and perhaps even its future. But to understand, we must learn to listen. This language isn't easy to decipher. It's not a set of easily recognizable words or phrases. It's a complex, interwoven tapestry of sounds, each one influenced by a myriad of factors: temperature, pressure, the flow of water, the shape of the land beneath. It requires patience, careful observation, and a willingness to embrace the unknown. Imagine the immense weight of the ice, pressing down with unimaginable force. It deforms, it compresses, it slowly molds itself to the contours of the bedrock. Below, this constant pressure generates a chorus of creaks and groans, each one a testament to the incredible forces at play. Then there's the movement of the ice itself. The glaciers, those slow-motion rivers of ice, are constantly flowing, grinding their way towards the sea. As they move, they fracture, they shear, they collide with the landscape, creating a symphony of subtle shifts and vibrations. And don't forget the water. The hidden network of rivers and lakes beneath the ice exerts its own influence, lubricating the base of the glaciers, allowing them to slide more easily. The movement of this water creates its own set of sounds: the gentle gurgle of a subglacial stream, the distant rumble of an underground waterfall, the subtle shift of a subglacial lake as it expands and contracts. These sounds aren't just random noise, they're clues. They tell us about the internal structure of the ice, about the presence of hidden crevasses and fractures, about the flow of water beneath. They can even tell us about the composition of the ice itself, about the presence of air bubbles and other impurities that can affect its acoustic properties. Learning to interpret this language of ice is like learning to read a book written in an ancient, forgotten tongue. It requires painstaking effort, a deep understanding of the context, and a willingness to make mistakes. But the rewards are immense. By deciphering the sounds of the ice, we can unlock secrets about the Earth's past, about its present state, and about its future. Think of the ancient air bubbles trapped within the ice. Bubbles that contain samples of the atmosphere from thousands of years ago. These bubbles are like tiny time capsules, preserving a record of past climates. By analyzing the composition of these bubbles, scientists can reconstruct the Earth's climate history and gain insights into the forces that drive climate change. And then there's the water. The water beneath the ice contains microorganisms, ancient life forms that have been isolated from the surface world for millions of years. These organisms are adapted to the extreme conditions of the subglacial environment, and they may hold clues about the origins of life itself. So, the next time you hear the sound of ice, whether it's the gentle crackle of ice cubes in your drink or the distant rumble of a glacier, take a moment to listen. Remember that the ice is not just a frozen substance. It's a dynamic, ever-changing entity, filled with hidden stories and secrets waiting to be discovered. It's a language spoken not in words, but in groans, creaks, and shifts. A language that, with patience and careful listening, can reveal the profound mysteries hidden beneath the frozen surface of our planet. It's a reminder that even in the most seemingly barren landscapes, there is a symphony of life and history unfolding, waiting for us to tune in and listen. So, how do you listen to something so vast, so profoundly silent? How do you hear the whispers of a continent buried under miles of ice? It's not as simple as sticking your ear to the frozen ground, though the thought is appealing. It requires patience, ingenuity, and a deep understanding of the physics that govern this alien world. Think of it like this: the ice isn't just frozen water. It's a record player, a massive, slow-moving archive of Earth's history. Every layer of ice, every grain of snow, every trapped bubble of air holds a story, a fragment of a climate long past. The problem is, the record is buried, the needle is broken, and the music is playing at a glacial pace. Our job, then, is to rebuild the needle, to decipher the code, and to speed up the playback. We need to learn the language of the ice, to understand the nuances of its groans and creaks, the subtle shifts in its weight and density. And that means listening in ways that were unimaginable just a few decades ago. The first step is understanding the different kinds of sounds the ice makes. Some are obvious: the thunderous crack of a calving glacier as it breaks off into the sea, the grinding rumble of ice sheets as they slide over the bedrock, the sharp snap of ice crystals fracturing under pressure. These are the loud, dramatic pronouncements of the ice, the equivalent of shouting in the vast, white wilderness. But the real secrets lie in the quieter sounds, the almost imperceptible vibrations that travel through the ice like whispers carried on the wind. These are the sounds of internal stress, of melting and refreezing, of water flowing beneath the ice sheet, carving out hidden channels and filling subglacial lakes. They're the sounds of life, of motion, of a world in constant flux, even in the heart of the frozen continent. To hear these whispers, scientists use a variety of sophisticated tools. Acoustic sensors, buried deep within the ice, act like highly sensitive microphones, picking up the faintest vibrations and translating them into audible signals. These sensors can detect the movement of water, the fracturing of ice, and even the presence of microbial life within the subglacial environment. Imagine setting up a vast network of these microphones across the continent, a web of listening posts that stretches for hundreds of miles. Each sensor is like a single ear, listening intently for the faintest sounds, recording every groan, every creak, every ripple. Together, they create a symphony of the ice, a complex and ever-changing soundscape that reveals the hidden workings of the Antarctic landscape. But simply recording the sounds isn't enough. We need to interpret them, to translate them into meaningful information. That's where radar comes in. Radio waves can penetrate deep into the ice, bouncing off different layers and surfaces, creating a detailed picture of the subglacial environment. Think of it like sonar, but instead of using sound waves to map the ocean floor, we're using radio waves to map the landscape beneath the ice. By analyzing the strength and timing of the returning signals. We can determine the thickness of the ice, the shape of the bedrock, and the presence of water. Combine radar with acoustic data, and you begin to get a truly comprehensive picture of the hidden world beneath the ice. The radar provides the visual map showing the contours of the landscape, the shape of the rivers and lakes. The acoustic sensors provide the soundtrack, revealing the dynamic processes that are shaping the landscape in real time. For example, by comparing radar images taken over time, we can track the movement of subglacial water, identifying areas where melting is occurring and where water is accumulating. By analyzing the acoustic signals, we can pinpoint the source of the melting, whether it's geothermal heat, friction from the ice sheet sliding over the bedrock, or changes in ocean currents. This combination of radar and acoustic data allows scientists to create detailed models of the subglacial environment, simulating the flow of water, the movement of ice, and the interaction between the ice sheet and the bedrock. These models are crucial for understanding the dynamics of the Antarctic ice sheet and for predicting its future behavior. But beyond the scientific applications, there's something deeply poetic about this process of listening to the ice. It's a reminder that even in the most seemingly silent and barren places, there's always a story to be told, a voice waiting to be heard. It requires patience, empathy, and a willingness to look beyond the surface, to listen for the whispers that resonate in the depths. And in those whispers, we may just find answers to some of our most pressing questions about the past, the present, and the future of our planet. These sensors are not just ears pressed against ice. They are the stethoscopes of the planet, listening to the very slow heartbeat of an ancient world. Imagine slicing through time, a colossal ice core rising from the depths, each layer a delicate page ripped from Earth's diary. These aren't just records of frozen water. They're archives of ancient atmospheres, whispering tales of climates long vanished, of landscapes transformed. Within these icy tombs lie secrets that can rewrite our understanding of the planet's past and offer chilling predictions about its future. Think about it. Trapped within each ice crystal are microscopic bubbles of air, perfect samples of the atmosphere as it existed thousands, even hundreds of thousands of years ago. By analyzing these bubbles, scientists can reconstruct past temperatures, atmospheric composition, and even the levels of greenhouse gases that blanketed the planet. It's like having a time machine, allowing us to step back and witness the Earth's climate in its infancy. These ice cores reveal a planet that has undergone dramatic shifts, cycles of warming and cooling far beyond anything we've experienced in recent human history. They show us that the Earth's climate is a dynamic, ever-changing system, prone to both gradual transitions and sudden, catastrophic events. The deeper we delve into the ice, the further back we travel, the more profound and unsettling these revelations become. But it's not just atmospheric data locked within the ice. Buried alongside those ancient air bubbles are traces of life, remnants of ecosystems that thrived in conditions vastly different from today. Pollen grains, fossilized algae, and even fragments of ancient insects are entombed within the ice, offering glimpses into lost worlds. Imagine a landscape teeming with life where now only ice reigns. Picture forests stretching across the continent, supporting diverse animal populations, thriving in a climate far warmer than the desolate expanse we see today. The ice holds the clues to these vanished ecosystems, hinting at the resilience and adaptability of life in the face of drastic environmental change. And perhaps most intriguingly, these icy archives may even harbor evidence of microbial life, bacteria and other microorganisms that have been frozen in time for millions of years. These tiny organisms represent a vast untapped reservoir of genetic diversity, potentially holding the key to understanding the origins of life on Earth and the limits of its adaptability. Consider the implications. If life can survive for millions of years in the extreme cold and pressure of the Antarctic ice sheet, what other secrets might be hidden in the frozen depths of our planet? What other forms of life might exist in similarly harsh environments elsewhere in the solar system? The study of these ancient microbial ecosystems isn't just an academic exercise. It's a quest to understand the very nature of life itself. It challenges our assumptions about what is possible, pushing the boundaries of scientific knowledge and opening up new avenues of exploration. But these icy archives are not invulnerable. As global temperatures rise, the Antarctic ice sheet is melting at an alarming rate, threatening to erase these precious records of the past. The very data that could help us understand and mitigate the effects of climate change is being lost to the very phenomenon it could help us combat. The melting ice is not just a scientific tragedy. It's a loss of history, a silencing of voices from the past. It's a reminder that the choices we make today will have profound consequences for generations to come. So, as you contemplate the vastness of the Antarctic landscape, remember that beneath the surface lies not just a frozen wasteland, but a treasure trove of ancient secrets waiting to be unlocked. Listen closely to the whispers carried on the wind, the echoes of forgotten life resonating within the ice. For within those whispers lies the key to understanding our past, navigating our present, and safeguarding our future. The story of Antarctica is not just a story of ice. It's a story of life, of resilience, and of the enduring power of the planet to surprise and inspire us. It is a story written in ice, and one we must learn to read before it melts away forever. Acoustic sensors and radar. How scientists listen to the ice. Imagine placing a stethoscope, not on a chest, but against the vast, frozen heart of Antarctica. What would you hear? Not the steady thrum of life as we know it, but a symphony of subtle sounds, a language spoken in the groans and whispers of ice. Scientists are doing just that, employing an array of sophisticated tools to eavesdrop on this hidden world. First, consider acoustic sensors. These incredibly sensitive instruments, lowered into boreholes, drilled deep into the ice, act as underwater microphones, capturing the faint vibrations that ripple through the liquid realm beneath. These vibrations aren't random noise. They're echoes of activity, clues to the dynamic processes unfolding in the subglacial environment. What kinds of sounds are we talking about? The creak and grind of ice sheets sliding over bedrock, the rush of meltwater carving new pathways, the subtle tremor of a subglacial volcano awakening from its slumber. Each sound is a data point, a piece of the puzzle that helps scientists understand how the ice is moving, how the landscape is changing, and how the subglacial water system is functioning. The information gleaned from these acoustic sensors is invaluable. It allows researchers to track the flow of subglacial rivers, to monitor the stability of ice sheets, and to detect potential hazards, such as the sudden release of meltwater that could impact sea levels around the globe. It's like having a network of spies embedded within the ice, sending back vital intelligence from a world we can't directly access. But listening alone isn't enough. To truly understand the architecture of the subglacial world, scientists need to see through the ice, to create a three-dimensional map of the rivers, lakes, and mountains that lie hidden beneath. This is where radar comes into play. Imagine shining a powerful beam of light through a dense fog. The light will scatter, revealing only a hazy outline of what lies ahead. Now replace the light with radio waves and the fog with miles of solid ice. Suddenly, the impossible becomes possible. Radar, or radio detection and ranging, uses radio waves to penetrate the ice, bouncing off different layers and surfaces below. The principle is simple. Radio waves travel at a known speed. By measuring the time it takes for a radar pulse to travel to a target and return, scientists can calculate the distance to that target. By systematically scanning the ice sheet with radar, they can create a detailed map of the subglacial topography, revealing the hidden valleys, canyons, and mountains that shape the flow of ice and water. Think of it as an underwater sonar system, but adapted for ice. A plane equipped with radar equipment flies in precise lines across the Antarctic landscape, emitting pulses of radio waves that penetrate the ice. The returning echoes are then processed by powerful computers, creating a virtual model of the subglacial world. The data generated by these radar surveys is astonishing. It reveals the sheer scale and complexity of the subglacial landscape, a world of hidden features that rival those on the surface. We see vast, winding river channels carved into the bedrock, enormous subglacial lakes stretching for hundreds of kilometers, and towering mountains that rise thousands of feet above the surrounding plains. These radar maps are not just pretty pictures. They are essential tools for understanding the dynamics of the Antarctic ice sheet. By mapping the subglacial topography, scientists can predict how ice will flow, how meltwater will accumulate, and how the ice sheet will respond to changes in climate. Imagine tracing the path of a subglacial river as it winds its way through a hidden canyon, eventually emptying into a vast, dark lake. Imagine visualizing the contours of a mountain range buried beneath miles of ice, shaping the flow of ice like a giant, frozen hand. These are the kinds of insights that radar provides, allowing us to see the invisible forces that are shaping our planet. The combination of acoustic sensors and radar creates a powerful synergy, allowing scientists to listen and see through the ice, to understand the subglacial world in unprecedented detail. It's a testament to human ingenuity, to our ability to develop innovative technologies that allow us to explore the most remote and challenging environments on Earth. But perhaps the most profound impact of these technologies is the way they challenge our perceptions of Antarctica. They remind us that this seemingly barren continent is not a static, lifeless wasteland, but a dynamic, ever-changing landscape teeming with hidden activity. They reveal a world of subterranean rivers and lakes, a world of ancient climates and forgotten ecosystems, a world that is just beginning to reveal its secrets. And as we listen to the whispers of the ice, as we map the hidden landscapes beneath, we begin to understand that Antarctica is not just a place on a map. It's a vital part of our planet's system, a key to understanding our past, and a crucial indicator of our future. So, the next time you look at a map of Antarctica, remember what lies beneath. Remember the hidden rivers, the ancient lakes, the slow, deliberate currents that shape this frozen continent, and listen for the whispers of the ice, the faint echoes of a world waiting to be discovered. Imagine the challenge, a world hidden beneath miles of solid ice. How do you even begin to map something you can't see? How do you chart the course of rivers flowing in perpetual darkness, or define the edges of lakes trapped beneath a frozen continent? The answer lies in echoes. It's about sending out signals and listening intently to what bounces back. Think of it like this: you're in a vast, dark cave, and you need to find your way around. You can't see, but you can shout. The echoes that return to you, the way they bounce off the walls and the ceiling, the time it takes for them to reach your ears. All of this information helps you to build a mental picture of the space around you. That's essentially what scientists are doing in Antarctica, but on a scale that's almost incomprehensible. The primary tool in this endeavor is radar, specifically ice penetrating radar. This technology sends out radio waves that travel through the ice, reflecting off different layers of ice, bedrock, and, crucially, water. The strength and timing of these reflections provide a wealth of information. A strong, clear echo might indicate a smooth surface of bedrock, while a weaker, more diffuse signal could suggest a layer of sediment or a pocket of slushy ice. And, of course, a very strong reflection would suggest the presence of water. But simply detecting water isn't enough. Scientists need to map the extent of these subglacial lakes and rivers to understand their depth, their shape, and how they connect with each other. This requires incredibly precise measurements and sophisticated data analysis. The radar data is collected by aircraft flying over the ice sheet or by researchers using ground-based radar systems. These systems are towed behind snowmobiles or specialized vehicles, crisscrossing the landscape in carefully planned patterns. As the radar signals bounce back, they are captured by sensitive receivers and processed by powerful computers. The raw data is then transformed into detailed images of the subglacial landscape. These images are not like photographs. They are more like sonograms, representing the density and composition of the materials beneath the ice. But radar isn't the only tool in the box. Seismic surveys offer another complementary way to see through the ice. These surveys involve generating vibrations at the surface, either by setting off small explosions or using specialized vibrating trucks. These vibrations travel through the ice and into the underlying rock, reflecting and refracting as they encounter different geological features. By carefully measuring the arrival times and amplitudes of these seismic waves at various locations, scientists can build a three-dimensional model of the subglacial world. Seismic surveys are particularly useful for determining the thickness of the ice sheet, the depth of the bedrock, and the presence of faults and other geological structures. They can also provide information about the properties of the subglacial sediments, such as their density and porosity. The data collected from radar and seismic surveys is often combined with other types of information, such as satellite imagery, gravity measurements, and magnetic field measurements, to create a more comprehensive picture of the subglacial environment. The amount of data collected is vast, and it requires a team of dedicated scientists and engineers to process and interpret it all. Once the data has been processed and analyzed, it can be used to create detailed maps of the subglacial landscape. These maps show the location and extent of subglacial lakes and rivers, the topography of the bedrock, and the thickness of the ice sheet. They can also be used to model the flow of water beneath the ice, to understand how these subglacial systems interact with each other and with the surrounding environment. These maps are not just pretty pictures, they are essential tools for understanding the behavior of the Antarctic ice sheet and its impact on global sea levels. By mapping the subglacial world, scientists can better predict how the ice sheet will respond to climate change and what the consequences will be for coastal communities around the world. But beyond the practical applications, there is also something deeply inspiring about this work. It's a testament to human ingenuity and our relentless pursuit of knowledge. We are, in effect, listening to the Earth, deciphering its secrets, and learning about its past, its present, and its future. We are taking echoes from a world unseen and creating maps of a hidden realm, revealing a landscape that was once thought to be impossible to explore. And in doing so, we are expanding our understanding of our planet and our place within it. We've built this picture, piece by piece, a frozen continent humming with unseen activity, a landscape that defies easy categorization. But the biggest mistake we can make is to stop asking questions. It's human nature to simplify, to categorize, to create boxes for everything we observe. Frozen wasteland, barren landscape, dead zone. These are convenient labels, but they are also profoundly misleading. What if everything we think we know about Antarctica is just scratching the surface? What if the true story lies not in what we can see, but in what we choose to look for? What if the absence of obvious life is not an absence at all, but simply a different kind of existence, adapted to a reality we can barely comprehend? Think about it. We define life by certain parameters: sunlight, warmth, readily available nutrients. But those are just our parameters, based on our experience. What if life can flourish in the absence of sunlight? What if it can thrive on chemical energy derived from rocks? What if it can survive under immense pressure in temperatures that would instantly kill most surface organisms? We have to challenge our anthropocentric view, our tendency to project our own limitations onto the rest of the universe. Just because we can't imagine surviving in a particular environment doesn't mean that nothing can. The beauty of science is its constant process of reevaluation, its willingness to abandon old assumptions in the face of new evidence. And Antarctica is a treasure trove of such evidence, a laboratory for testing the very limits of life. Every time we drill into the ice, every time we send a probe into a subglacial lake, every time we listen to the groaning of the ice sheets, we are confronted with new possibilities, new challenges to our understanding. Consider those organisms that thrive in conditions that would be lethal to most other life forms. They live in volcanic vents, in highly acidic environments, in the deepest parts of the ocean. And yes, they live beneath the ice of Antarctica. These microscopic pioneers are a reminder that life is tenacious, adaptable, and incredibly resourceful. They show us that the boundaries we draw between habitable and uninhabitable are often arbitrary, based on our own limited perspectives. And it's not just about the organisms themselves, it's about the ecosystems they create. Even in the darkness of a subglacial lake, complex food webs can exist, sustained by chemosynthesis rather than photosynthesis. These hidden worlds are self-contained, self-regulating, and utterly unique. They represent a parallel biosphere, operating according to different rules, challenging our very definition of what constitutes a living system. So, when you look at a map of Antarctica, don't just see a white void at the bottom of the world. See a continent teeming with potential, a place where the laws of nature are being tested and redefined. See a place that forces us to confront our own preconceptions, to question our assumptions, and to open our minds to the possibility of the unknown. It's easy to be lulled into complacency, to accept the easy answers, to rely on the familiar narratives. But true discovery requires a willingness to venture beyond the comfort zone, to embrace the uncertainty, and to challenge the status quo. And perhaps, more importantly, to acknowledge what we don't know. Think about the early explorers, those who dared to venture into the unknown, armed with nothing but rudimentary maps and a burning desire to see what lay beyond the horizon. They faced unimaginable hardships, endured brutal conditions, and risked their lives to push the boundaries of human knowledge. Their courage and perseverance are a testament to the human spirit, a reminder that we are capable of achieving the seemingly impossible. We must adopt that same spirit of exploration, that same willingness to challenge the unknown when we approach Antarctica. We must be willing to look beyond the surface, to delve into the hidden depths, and to listen to the whispers of the ice. Because within those whispers, within those hidden depths, lies the key to understanding not just Antarctica, but the planet as a whole, and perhaps even ourselves. It's a journey that demands intellectual humility, a recognition that our current understanding is always incomplete, always subject to revision. It's a journey that requires collaboration, a pooling of knowledge and expertise from different disciplines, from different cultures, from different perspectives. It's a journey that ultimately leads to a deeper appreciation for the interconnectedness of all things, for the delicate balance that sustains life on Earth. So let's not settle for easy answers. Let's not be content with surface judgments. Let's embrace the mystery, the complexity, and the sheer wonder of Antarctica. Let's look beyond the surface and open our minds to the possibility of a world beyond our wildest imaginations. Because the true discoveries are always waiting just beyond the edge of what we think we know. We've peered beneath the surface, haven't we? We've listened to the whispers of a world unseen, mapped the hidden rivers that carve pathways through the Earth's frozen heart, and perhaps, in doing so, we've begun to understand something profound about potential itself, about the power that lies dormant, waiting for the right conditions to bloom. Think of the seeds buried deep beneath the snow, awaiting the warmth of spring. Think of the untapped energy within a sleeping volcano, the slow, inexorable buildup of pressure that one day will reshape the landscape. Antarctica, in its frozen embrace, is a masterclass in this hidden potential. It's a testament to the fact that what appears barren, lifeless even, can be brimming with possibilities, just waiting to be unlocked. Imagine the darkness of those subglacial lakes, untouched by sunlight for millennia. You might expect them to be sterile, devoid of any life, and yet teeming ecosystems thrive there, fueled by chemosynthesis and the faint energy of the earth itself. These organisms, these hardy microbes, have adapted to the impossible, carved out a niche in the face of unimaginable adversity. They are a living embodiment of resilience, a reminder that even in the most extreme conditions, life finds a way. And isn't that a powerful metaphor for our own lives? How often do we underestimate our own potential, dismiss our own capabilities, simply because we haven't been tested, haven't been pushed to the edge? How often do we mistake the stillness of our outer lives for a lack of inner fire? Antarctica challenges us to question these assumptions. It reminds us that beneath the surface, beneath the mask of ice and snow, there lies a world of hidden energy, of untapped potential, of possibilities we can scarcely imagine. It's a place where the impossible becomes reality, where the boundaries of what we think is possible are constantly being redefined. Consider the scientists who dedicate their lives to exploring this frozen continent. They face extreme conditions, isolation, and logistical challenges that would deter most, and yet they persevere, driven by a relentless curiosity, a desire to understand the secrets hidden beneath the ice. They are pioneers, pushing the boundaries of human knowledge, revealing the hidden wonders of our planet. Their work is not just about scientific discovery, it's about challenging our perceptions, about expanding our understanding of what it means to be human, about recognizing the boundless potential that lies within us all. It's about embracing the unknown, stepping into the darkness, and trusting that even in the most challenging circumstances, we are capable of achieving extraordinary things. So, as you contemplate the frozen majesty of Antarctica, remember the hidden rivers, the ancient lakes, the resilient ecosystems that thrive beneath the ice. Remember the scientists who dedicate their lives to unraveling its mysteries. And remember the profound lesson that this frozen continent has to offer, that within each of us there lies a realm of hidden potential, a place where the impossible can become reality, a reservoir of strength waiting to be tapped. It's a reminder that even when we feel frozen, stuck, or incapable, there's always a current of possibility flowing beneath the surface, waiting for the right moment to break through. It's a call to embrace the unknown, to explore the depths of our own being, and to discover the extraordinary potential that lies within. Just as the ice holds secrets, so too do we. The key is to listen, to learn, and to believe in the power of what lies hidden, waiting to be revealed. Because sometimes the greatest discoveries are not made on the surface, but in the depths, in the quiet, in the darkness, in the places where the impossible becomes reality. And in that potential, we find the true measure of our strength. But what does it all mean? Beyond the data, beyond the maps, beyond the scientific breakthroughs, what is Antarctica truly teaching us? It's not just about the resilience of microscopic life in a subglacial lake, or the surprising fluidity of an ice sheet under immense pressure. It's about us. It's a mirror reflecting our own potential, our own hidden depths, our own capacity to endure and even flourish in the face of seemingly insurmountable odds. Think about it. We often judge ourselves and others based on what we see on the surface. We see a calm exterior, a stoic facade, and assume that's all there is. We see a person who appears to be struggling, and we assume they are weak. We see a challenge that seems impossible, and we give up before we even begin. But Antarctica, with its hidden rivers and its ancient lakes, whispers a different story. It tells us that beneath the surface, beneath the ice, there is always more. There is a hidden current of strength, a reservoir of resilience, a wellspring of potential waiting to be tapped. Just like the subglacial rivers that carve pathways through the bedrock, we too possess the power to overcome obstacles, to adapt to change, to find our own unique path forward, even in the darkest of times. Consider the scientists working in Antarctica. They face extreme conditions, isolation, and technical challenges that would deter most people. Yet they persevere. They are driven by a deep curiosity, a passion for discovery, and an unwavering belief in the importance of their work. They are, in a way, explorers of their own inner landscape, pushing the boundaries of what is possible, both scientifically and personally. And that's the true beauty of Antarctic exploration. It's not just about mapping the hidden world beneath the ice. It's about discovering something new about ourselves in the process. It's about learning to listen to the whispers beneath our own feet, to recognize the hidden currents that flow within us, to embrace our own capacity for resilience. Perhaps you're facing a challenge in your own life right now. Perhaps you feel like you're trapped beneath a layer of ice, isolated and overwhelmed. But remember the story of Antarctica. Remember the hidden rivers, the ancient lakes, the life that thrives in the darkness. Remember that even in the most extreme environments, there is always hope, there is always potential, there is always a way forward. Look inward, explore your own subglacial world. What hidden strengths do you possess? What reservoirs of resilience lie dormant within you? What untapped potential is waiting to be unleashed? Don't be afraid to delve deep, to explore the uncharted territories of your own being. You might be surprised by what you discover. Just as scientists use radar and seismic surveys to map the hidden landscape of Antarctica, you can use introspection, mindfulness, and self-compassion to map your own inner landscape. Listen to the whispers beneath your own surface. Pay attention to the subtle cues of your emotions, your thoughts, and your intuition. These are the currents that flow beneath the ice, guiding you towards your own unique destination. The journey to the bottom of the world is ultimately a journey to the center of yourself. It's a reminder that even in the face of overwhelming challenges, we are capable of remarkable resilience, profound adaptation, and enduring strength. So, embrace the stillness, listen to the whispers, and embark on your own journey inward. The secrets you discover may just change your life forever, because, like Antarctica itself, you are more than meets the eye. You are a world of hidden wonders waiting to be explored.